All right, so this is going on page 92 when we're done. This has just a tiny bit of new-ish information in there, and then some old business that we've already worked on. So the first thing is coordinates of a point on a circle. Notice it doesn't say a unit circle, okay? Because we know for the unit circle, our ordered pair is cosine theta, sine theta, right? We've known that for a while. We're comfortable with that. We can do that. Okay, but what if it's not a unit circle? So in 3-2, or even before that, we learned that cosine theta is x over r, sine theta is y over r. And for our unit circle, r was 1. That's why it worked out like it did. But if I want to actually solve for x here, I can multiply both sides by r and get r cosine theta equals x. For this one, I multiply both sides by r, and I get r sine theta, and that equals y. Okay? So that's why on this circle, for this ordered pair, instead of it just saying cosine theta, sine theta, it says r cosine theta, r sine theta. Those of you in AP Physics, that is just like your mg cosine theta, mg sine theta. Right? Does that sound familiar? What does the mg stand for? Okay, there you go. Gives you your distance and directions for your vectors, right? I think mg in this instance stands for magnitude, but I could be wrong. Could also be mass and gravity. It sounded good to me, but it is your magnitude and your direction is what it is. But nice, good. You were very confident. That was good. Okay. So, but anyway, that's where those coordinates come from. All right. So that way, if it's a unit circle, r is 1, it's still cosine theta, sine theta. That's not changing because it can't change. But in any other radius, then we just stick that in front of the cosine and sine for our angle. All right. So let's look at this ordered pair. Let's look at this first question. All right. So the figure above shows a circle of radius 4. Along with an equilateral triangle PQO, which of the following gives the coordinates for point Q? So here is point Q. Point Q is in the second quadrant. Knowing that much, which answer choice looks like it would be correct? D. Does D look pretty good since we're in the second quadrant? X value is negative? Okay, but let me ask you this. This is negative 4 times the cosine of 2 pi thirds. In the second quadrant, is cosine positive or negative? Negative. In the second quadrant, remember, all students take calculus, right? So in the second quadrant, cosine's negative. So this is actually negative times negative, which this would give me a positive value, not my answer. So be careful when you're going to eliminate things that you're eliminating from them for the right reason. You don't have to eliminate anything from the beginning. But I can tell you that's going to be a common misconception on this one. That's why I wanted to point it out. You with me on that? So that's how I know for sure that's not my answer. But let's go back and let's think about whether this has these answer choices or not, what I need to know about this, what I can assume and what I can't. What I can assume is absolutely nothing, right? What I know is that this is an equilateral triangle right here. Equilateral triangle means that all 3 angles are congruent. What would the measure of all 3 angles be? Give it to me in degrees, because I think most people would know in degrees. 60, okay? So, because when you're thinking about a triangle, or an equilateral triangle, you're probably thinking 60, you're probably thinking in degrees. That's okay, all right? So let's just stick with degrees just a little bit, and this is why knowing the first quadrant in degrees can be helpful. So each one of these is 60, right? Which means that these two here would each have to be what? 30. Which means that this angle is 60, yes? So 60 in radians is pi thirds. So at point P is at pi thirds. This is 60. If I go another 60 right here, what would this angle be? What's my second quadrant pi thirds angle? 2 pi thirds, okay? That's how I know where my angle is, okay? By understanding an equilateral triangle, because we do have to have some concept of an equilateral triangle in our work, just in general, whether it has to do with unit circles or not. So now I know what this angle is going from here to here. This angle here is 2 pi thirds. Yes? The ordered pair is the radius, which is 4. 4 times the cosine of 2 pi thirds. 4 times the sine of 2 pi thirds. So what is my answer? C. So it's that simple. We just had to figure out the angle and then go from there. Okay? We okay with that? Any questions? All right. So then let's look at this one. We have a circle of radius r along with the line y equals negative x. The circle and the line y equals negative x intersects at point r, o, and p. The coordinates of point P, that's this point right here, are 6 square roots of 2, negative 6 square root of 2. That's my point P right there. I want the value of R. Okay. Now I can use what I know about my ordered pairs here, but there's also a different way to do it, which might be a little better and safer. If I draw in my triangle, okay, and you think about how the triangles worked in that little flippy thing that we made, so that you put the right angle in the correct place, that we're going with the x-axis here. So that would mean that this is 6 square root of 2. This is negative 6 square root of 2 when you're talking about displacement. This is my radius. So given that information, what can I do to find R? Pythagorean theorem, exactly. So if I write down 6 square root of 2 squared plus negative 6 square root of 2 squared equals R squared. Is what I wrote down written down correctly? No. And you cannot have what's called a linkage error. I cannot write it down like this, which is incorrect, and then do it correctly, because then my work doesn't flow. You with me on that? This, if I just have this, all I'm squaring is that square root of 2. That is not my intention. My intention is this. Therefore, that is what I have to write in order for everything to flow. Then when I square 6 square root of 2, what do I get? I get 36 times 2, which is 72, plus 36 times 2, which is 72. It's R squared. R squared equals 144. R is just a positive 12 because the radius is always positive. Okay? We okay with that? What questions you got? Okay. Oh, yes. Pythagorean theorem only works with right triangles. Finding them, and you have to have 2 of the sides to find the third with Pythagorean theorem. But don't forget it exists, because sometimes the simplest option is your option, even though we can do other things. Like, that's going to be the best way to do that. Okay? Any questions about that? All right. Good deal. Then flip it over. Now, this circle up here, in hindsight, I should have taken it off, but I want you just to look at it and remember what these 4 ordered pairs are. Those are your ordered pairs for your quadrantal angles, right? And so now, I want you to not look at it, maybe even cover it up with one hand, and then write down the values of these with your other hand. Okay? Because you should be able to picture that, not just look at the circle and get it, but picture that and come up with these values. Your only options for the answers are 0, 1, and negative 1. That's it. The only answers you can give me in example 3. Okay? I'll give you a second. Give me those cosine and sine values. Ask your neighbors. Are you sure? Yeah, I don't know. Are you sure we didn't literally just talk about it? Pretty sure it's even on the front of your notes. I'm just saying, oh. Oh.
哦
Good. Okay, good job.
哦
Good job. when you're done, check yourself up here. So what you need to be able to do is, excuse me, just kind of picture in your mind where that ordered pair is, and then think about what the ordered pair is before you pick the x or y coordinate, because these are the easiest ones, but they're the ones that seem to be wrong the most, because some of you don't know the difference between x and y, but also I think sometimes you're just thinking too quickly, and you're not giving yourself that like extra second just to make sure you have the ordered pair correctly. Okay, are we all good on that? Any questions? All right, so let's talk back through some of these, because we did this not too long ago. We're, again, practicing again. We got to practice, practice, practice. So when you have trig values, your special values that are not in the first quadrant, you want to think through a couple of things. So in A, I have the sign of 2 pi thirds. So the first thing I want to think is, what quadrant is 2 pi thirds in? Second. And then in the second quadrant is sign positive or negative? Positive. So now, don't even care about the 2 pi thirds or the quadrant anymore. I can just think about pi thirds. What is the sign of pi thirds? Yeah, here's pi thirds. It is square root of 3 over 2. Okay. Then we have cosine of 5 pi fourths. What quadrant is 5 pi fourths in? Third. And the third quadrant is cosine positive or negative? Negative. So I know it's negative. And then what is the cosine of pi fourths? Square root of 2 over 2. Very good. All right, 11 pi 6. What quadrant is that in? Fourth. In the fourth quadrant, cosine positive or negative? Positive. What is the cosine of pi 6? Pi 6, square root of 3 over 2. Square root of 3 over 2. Okay. We understand the thought process there? Remember doing that? All right, so now I'm going to give you a couple of minutes, and I want you to work on the rest of these. If you need to talk amongst yourselves, that's fine. Help each other out. Check your stuff with each other. We're doing all right? Yeah? We're doing all right over here? How are we doing? We doing all right? Think so? So you got 0, pi 6, pi 4s, pi thirds, pi halves, just like on the circle. So if it's pi thirds, this is the cosine, this is the sine. This means 1/2, this means the square root of 3 over 2. So if it's pi 6, cosine is the square root of 3 over 2, sine is 1/2. No, this is just the square root of 3 over 2, just 1/2. You don't put the fingers together. Pi 4, square root of 2 over 2, square root of 2 over 2. No, I'm not understanding. Or in the second quadrant, the numerator is 1 less than the denominator. In the third quadrant, the numerator is 1 more than the denominator, if you ignore the pi. So like 2. This one? No, see, the numerator is 1 less than the denominator, so this will be in the second quadrant, because 2 is 1 less than 3. And in the 4/3, that would be in the third quadrant, because 4 is 1 more than 3. Does that make sense? Okay. That's why we say we go to the x-axis and you back up 1 or go forward 1 from whatever's in the numerator or in the denominator. Okay? That help? All right, so we're going to start going through these. Good discussions around here. I heard y'all telling each other the different ways it helps you remember. I'm going to call on you. I'm going to do it on my iPad, though, since I'm recording. That way your name's not broadcast to everybody. So you can do a couple of things, because I know some of you may not have finished all of them. Most of you did, but that's okay if you're not. You can give me the answer, or if you're not sure, you can say, I need help. Or if you just haven't really gotten to it yet, maybe you say, give me a second, let me process this. So you can process it out loud. That's fine. We can hear what's going on in your brain. All right, so my first assistant is not here. Jesus, what did you get for D? Okay, negative square root of 2 over 2. Do we agree with this? Yes, good job, thank you. E, the cosine of 4 pi thirds. Kara, what did you get? You got what? You got negative 1/2. Do we agree with that? Yes, because 4 pi thirds is in the third quadrant, right? Good, thank you. Brittany, F, sine of 7 pi 6. Okay. Can you tell me what quadrant it's in? It is in the third. Is sine positive or negative in the third? Very good. Okay, so now then just tell me what is the sine of 6? 1/2. So my answer is negative 1/2. Right? Got it? Good job. All right, Megan, what's the cosine of pi? Negative 1. Do we agree with that? Yes, thank you. Pause. All right, so let's go. We still have some confusion about things, so let's make sure. Oh, this is going to be bad. We're going to pretend like I can draw this correctly. Oops. You don't necessarily have to write this down. Just stick with me here. When we're trying to figure out what quadrant things are in, all right? If this is pi 6ths, right? If I go to here, which is actually pi, I can think of this as 6 pi 6ths. I back up 1, I'm at 5 pi 6ths. Or I go forward 1, I'm at 7 pi 6ths. Make sense? Okay, so because I'm doing everything from the x-axis. So then this is 2 pi, which in sixths would be 12 pi 6ths, right? It's very hard to say. But if I'm at 12 pi 6ths, I back up 1, then I'm at 11 pi 6ths, okay? Do everything from the x-axis. So then when I'm at pi 4ths, 4 pi 4ths, I back up 1, that's 3 pi 4ths. I go forward 1, I'm at 5 pi 4ths. Then I'm at 8 pi 4ths. I back up 1, that gives me at 7 pi 4ths. Okay? See how that works? Just a little reminder here, because some of us are still struggling. Pi thirds. 3 pi thirds. This gives me 2 pi thirds. Go back to 3 pi thirds. I go forward 4 pi thirds. Then at 2 pi, that would be 6 pi thirds. I back up 1. That is 5 pi thirds. I left off my other quadrantals, but this is pi halves. Oh, that's a 3. Pi halves. This would be 2 pi halves. That makes this 3 pi halves. Okay? And what I heard some other people saying, this is how I remember it, is that in the second quadrant, if we ignore the pi's, the numerator is 1 less than the denominator. In the third quadrant, it's 1 more than the denominator. That's because we were here, then we backed up 1, or we were here, and we went forward 1. Does that help? Okay, there's tons of patterns there, so however you can picture what quadrant it's in, but I really think going from the x-axis and backing up 1 or going forward 1, I mean, that's really how it kind of all works out. Okay. I would not waste my time on that. I think you should just know it. By then, you should just know it. All right. Okay, so back over here. My next assistant, great discussions though. Abraham, sine of 3 pi halves, -1. Do we agree with that? What is your question, Gavin? Depends on what we're asking. Pi thirds is right here, right? This is cosine, 1/2. This is sine, square root of 3 over 2. All right, then cosine of 2 pi thirds. Paulina, what did you get? -1/2. Do we agree with that? Yep, because we're in the second quadrant. Cosine is negative there. All right, thank you. Herline, cosine of 5 pi thirds. 1/2. Y'all agree with that? Yes, because this is in the fourth quadrant and cosine is positive there. All right. Jocelyn, sine of 0. 0. Good job. Thank you. And then last but not least, Gael, cosine of pi halves. 0. We agree with that? Yes. Good job. All right, so we definitely need some practice on this, but make sure that you are, thank you, make sure that you are trying to get these out of your brain, that you're not just looking at a unit circle, that you were thinking about what quadrant am I in. Really, this is just kind of one of those drill and practice things, kind of like multiplication facts. The more you think about what quadrant is 2 pi thirds in, the less you'll have to think about that. Like, it'll just make sense kind of picturing it in your head. And then think about the sign, and then all of your values come from the first quadrant. Okay? Are we good? What questions you got? All right, good deal.